Continuing on. Remember, the first thing you have to do is set up the auxiliary equation. And squared plus 4m plus 5 equals 0 for this one. Then we solve it. Quadratic is simple to solve. Can that be factored in the standard way? No. So quadratic. What's a quadratic point?
Opposite of b, or plus or minus the square root of 4ac, or b squared minus 4ac over 2a.
And what do you notice?
Is it negative squared?
So what does that mean?
Is it an imaginary result?
Wow, be careful.
It's not a result.
We don't call it imaginary.
Oh.
It's complex.
Hmm.
But yes, complex result from the complex plane. Two solutions, -2 plus I and -2 minus I. Remember, when you have a complex solution, it always occurs in a pair. Because if you have one complex solution, so let's say Z is a complex solution, its conjugate is also a solution. For purposes of general solution, you look at the real component, call that alpha, and you look at the imaginary component, call that beta. Alpha is -2, beta is 1. And there are two ways to write the solution. You can either factor out the E, or just write it as actual two separate terms. C1 e to the alpha x times cosine of beta x plus C2 e to the alpha x times sine of beta x. And that's the general solution. So the equation m squared plus 4 equals 0. Right? What are the solutions?
And the square root,
Which is what?
which is plus or minus 4, and then your plus or minus
I agree there's an I.
or 2i.
Plus or minus 2i. What's the real component? imaginary component?
Oh.
What's the real component? 0. Because that can be written as 0 plus 2i. Oh, okay. Well, what's e to the 0? That means we have no e. And there's the general solution.
Where is the e to the
Comes out of the derivation. You have to use Euler's formula. Like you technically have e to the, in this case, you have e to the 2i and e to the negative 2i as your independent solutions. But they're complex valued functions. We want real valued functions. So making use of Euler's formula, we can write it this way. I'll do this one and then move on to higher orders. And then come back to the rest of the second orders if we have time. What's the auxiliary?
M squared plus x minus 3 plus 4.
Can that be factored? I mean, technically, the answer is yes. Every common number can be factored. Can be factored with just integer coefficients. No. 4 times 4, 16. And you should be able to see that we're going to get complex again. Discriminant is negative. What is the real component?
Three halves.
3 halves. What's the beta? Or what's the imaginary component?
Or 7 over 2.
7 over 2. I'm going to write it the second way this time, just to show it. E to the alpha x, then times the quantity C1 cosine beta x plus C2 sine beta x. So when dealing with second order, you're only going to have one out of the 3 possibilities. Your roots are either distinct, repeated, or complex. You can't have a mixture of them for second order. It's going to be one of those 3. And that's determined by the discriminant. Remember, a positive discriminant means you have distinct roots, distinct real roots. A discriminant of 0 means you have repeated roots, and a discriminant less than 0 means you have complex. But that's for second order. Once you get up to third order, you can have a mixture.
Go back to the so I guess for the equation, it's always going to be like the power of whatever number it is.
Whatever order the derivative is. So you say n is essentially y prime.
Yeah.
What is the auxiliary here?
And cubed minus 6 m squared plus 11 m minus 6 equals
I'm finding roots of polynomials larger than degree 2. What was the method? On algebra, you tried factor by grouping. That doesn't work here. That means you have to go on to the pre-calculus method if you're to do it by hand. Which is a long, tedious process. Are we in pre-calculus? Are we in pre-calculus? No. Well, I hope so.
Yeah.
If not, we're in trouble. Why? That's why. What's going on? What is going on?
Is there a way to do this with
Solve. Now you just type in the equation. And notice with Wolfram, you have to use a double equals. And then with respect to what? N. I also like to do this. It's just the layout. It's not mandatory. There are your 3 solutions. So I'll just do that. And here's the general strategy. Just go root by root. root is 1. Obviously, it's the first root, so it has not even appeared yet. Just e to the x. Now look at the second root. It's 2. Has that already appeared in our solution? So it's already an e to the 2x. No, right? So it's just e to the 2x. Third root. We give u to the 3x, and that has not occurred in our solution yet, so it's just e to the 3x. There's your general solution.
How would you do this?
You have to find the solve feature. And it's pretty much the same way. Alternatively, you could graph the polynomial and then use the find intercepts feature of the graph, which is a bit longer, but that also works. What's the auxiliary?
Ten to the 4th minus 9m squared plus 20 equals 0.
That is a quadric, right? But isn't that quadratic form? So treat it like a quadratic instead. Can that be factored? Can. Factors of 20 when added give 9, 45. Your higher factor has to be negative. Which makes that really easy to solve. What are your solutions?
You have plus or minus the square root of -5 or oh,
Just 5. Just root 5.
oh. And plus or minus I squared.
First root was negative root 5. Second root, positive root 5. None of them repeated. And typically I'll do all the real roots first, and then worry about the complex. For your complex solutions, what's the real component? Which is what for this one? What is the real component for our solution?
0.
0. There's no e. What's the imaginary component? What did I use C for? One of the complex solutions gives the cosine of 2x. Its conjugate would give the sine of 2x. And so those two are always grouped together. And there's your general solution. Again, make sure you have the proper amount of terms. Fourth order, you need 4 terms, and there are. What's the auxiliary?
N cubed minus 6m squared plus 2m plus 36 equals 0.
Can we very nicely factor that? No, sadly. So there's 3 solutions to the auxiliary. Should be, right, because it's third order. And I'm pretty sure Wolfram also lists your real solutions first. And generally, I think it lists them in ascending order, which is nice. C1 e to the negative 2x plus, now you look at your next 2 solutions, they are complex conjugates. So you really only need to look at one of them. What would the real component be for? And what is the imaginary component? And so again, how you write it, up to you. Could do e to the alpha x times, and then c2 cosine plus c3 sine. Or just write them individually. And that's the general.
Using the calculator, you said you used solve to do it. It said it was missing something when I did solve and just typed in the equation.
Did you tell it to solve with respect to what variable?
No. Do I have to do a
So then
comma?
comma and then What's the variable?
Inside the parentheses?
Yes.
Okay.
Yeah, I'm trying to figure out how to use this all at once. Let's see what this is.
What's the auxiliary here?
M to the fourth minus 4m to the third plus 7m squared minus 4. Or is it 4m? Yeah. Equals 0.
And here the dependent is x. Not quadratic form. Also can't group. So here we're definitely going to use some kind of aid. Menu algebra solve. Then the equation. So with respect to m.
You gotta use C solve.
False.
Mhm.
Oh. That means there's no real solutions. I'm pretty sure it's already bottom for complex.
You just click C though.
Complex and then solve. We'll give you the C solve. And then gives you your solutions. And Wolfram, you don't have to worry about that. Right, so these two pair together, and then those two pair together. So just look at the first pairing. What's your real component?
0.
What's the imaginary?
1.
So that first complex conjugate pair gives cosine of x and sine of x as two linearly independent solutions. Now look at that second pairing. What is the real component?
2.
And what is the imaginary?
Root.
And that second pairing gives e to the 2x cosine of root 2x and e to the 2x sine of root 2x as two linearly independent solutions.
So the negative doesn't matter.
Because they're conjugates. Even if you use the negative, you can still use the even and odd properties. Cosine and sine, you get the exact same thing. Right, so generally, we just look at the positive. And that's your general solution. It's the auxiliary equation.
M to the 4th plus 8m cubed plus 24m squared plus 32m plus 16 equals 0.
Can that be factored?
Can I see this line before?
Can you see it?
Yeah, like,
Well, right now you can,
okay.
right? It's not visible on the screen right now, is it? I think you want me to go back to it.
Yeah. So is the solution supposed to be y of x, or is it supposed to be x of t?
Oh, x of t. Yeah. You're so used to just x's. Can that be factored? Without calculator. They can't be. If you recognize it. That's m plus 2 to the 4th power. Knowing Pascal's triangle and the binomial theorem can be advantageous. Right, the row I'm looking at, the 4th row, which is 1, 4, 6, 4, 1. For Pascal's triangle is the coefficients. So it perfectly fits the binomial theorem. Yeah, or you could just plug it into an equation solver. Plugging into an equation solver should give you -2 4 times.
Just give it to me once.
Oh, that's not good.
Yeah.
Wolfram gives it to you on 4.
But you know that it's 4 because of the highest power.
Well, you know that's V4 solutions. So unless you use C-solve and see no complex solutions, you don't know if that occurs once or twice. Or I'm sorry, twice or 4 times. And so you have to have an even number of complex solutions. And this is y-x. First, limit the independent solution would be e to the -2x. Second would be e to the -2x, but we have that already, don't we? Using reduction of order, or I think your textbook refers to it as a bell, you'll wind up with x e to the -2x. Again, that was derived already, so I'm not going to go through that derivation. Third root is also -2. Well, we already have e to the -2x. We already have x e to the -2x. So now we multiply by x squared. Fourth root is also -2. We already had -2. How many times before? 3. So you multiply by an x cubed. And there's your general solution. So whenever a root repeats, you multiply your e to, that e to the power by x raised to the however many times it's already occurred power. Your fundamental set, right, is just the e to the -2x, x e to the -2x, x squared e to the -2x, and x cubed e to the -2x. That's your fundamental set of solutions. Yes, which means unlike in algebra where you didn't really care about multiplicity too much, here you do. What is the auxiliary?
Times minus times minus 2 1 cubed plus 2 1 squared and plus minus
Minus what?
minus, speed.
1.
Minus
And equals 0. That's what you're going to wind up with. P of t, C1 e to the negative t, right? Plus C2, the root's negative 1, and we had it once before, t e to the negative t. Oh, do not open. Thank you. Plus C3, root is 1. That's the first time it's come up, so it's C3 e to the t. C4 root is 1. We've already had it. T e to the t. Plus C5 root is 1. We already had it twice before. T squared e to the t. And there's your general solution. Which means the hardest part of these is solving the auxiliary equation. After that, it's then literally just like a cookbook. You follow the recipe. Is it a distinct root? Here's the form. Is it repeated? Here's the form. Is it complex? Here's the form. We're real quick since I'm almost out of time. Auxiliary. This is going to lead if you plug in the rule from that. 2 minus 2i with a multiplicity of 2, 2 plus 2i with a multiplicity of 2. These are repeated complex roots. But the idea is the same. Those two are from the first pair, right? Then you move on to the second pair. But it repeated, which means you have to multiply each one by 2. And that would be your general solution. And again, you don't have to write it that way. There's another way that it's often written. also see it written that way. Doesn't matter. Questions on solving homogeneous linear equations with constant coefficients. Notice that all the coefficients have been constants. We'll deal with if they're variable later. And that's a bit more of a pain. Okay. Again, the hardest part is solving that auxiliary, right?
Just using the calculator. What were you saying about if it doesn't show the repeated answers? How do you do that?
So if you use C-solve, it's only showing the 2, right?
Mm-hmm.
You know there has to be 4 solutions. So you know that it repeats.
But in the previous one, it was like -1 repeated twice and then 1 repeated 3 times. So then how would you know that?
You have to factor it. You have to use the factor command.
Okay.
So you just do factor your polynomial, and then it should give it to you as m plus 1 squared times n minus 1 cubed, which would tell you that -1 has a multiplicity of 2 and 1 has a multiplicity of 3. That's what you have to do.
Okay.
Okay, so get into your groups. Moving on to solving non-homogeneous equations. So remember, non-homogeneous, your g of x function is not 0. What we do is we first find what's called the complementary function, which is just solving the homogeneous equation, which we just did. Then you have to find a particular solution. There are 3 methods for that. There's undetermined coefficients, the annihilator method, and then variation of parameters. I'm ignoring annihilator, because it's very similar to undetermined coefficients. We look at undetermined coefficients today. All right. For undetermined coefficients, what you do is you guess a form of your particular solution based on the form of g of x. This can only be used if g of x is a specific form. A polynomial, an exponential involving trig, or any combination of their sum products. Right, then your y of p is the same format as g of x. And so if g of x is an exponential, your y of p is going to be an exponential. If it's a product of a polynomial and a trig function, then your yp is the product of polynomial and trig function. And we'll go in depth. And so find general solution. The first step is to find the complementary function. And that's just solving that, which we just did. Right, so auxiliary equation, find your roots. I believe we may have already solved that.
So then the complementary
complementary function is the solution of the homogeneous equation. There's our complementary function. Okay, it's the general solution of the homogeneous. So that's not too difficult. Now we find the particular. This is where you look at g of x. So what does it equal? For x squared, right? What kind of polynomial is that? That is a polynomial. What's the degree?
2.
It's a quadratic. That's a form of a general quadratic, ax squared plus bx plus c. That's the form we picked for the particular. What we now have to do is find a, b, and c. You can either do this by hand or using technology. Let's start by hand. Our differential equation is second order, right? So we need the first and second derivatives. What's yp prime? To ax plus b, right? And what's yp double prime? Just 2a. Now plug that into the differential equation. Which was y double prime minus y prime minus 2 times y. That has to equal 4x squared. The method that we're now going to use should be familiar. It's the exact same method as when you did partial fraction decomposition. It's called coefficient comparison. We have a negative 2ax squared, right? Plus our x terms. Minus 2a minus 2b. And then the constant. 2a minus b minus c, or 2c. Coefficient comparison works this way. Look on the left-hand side. What's the coefficient of the x squared term? Left-hand side.
Oh. 2a.
Negative 2a. What is the coefficient on the right-hand side? Negative 2a has to equal 4. Look at the x term. Left-hand side, what is your coefficient? What is it on the right-hand side? Constant, what is it on the left-hand side? And what was it on the right-hand side? That is now a system of 3 equations and 3 unknowns. Love it. This system is very easy to solve by hand. More complicated systems, you could either use technology straight up, using the solve command, or you could use the method of elimination taught in algebra, or if you've had linear algebra, you can use the method taught in linear algebra, which is the best, outside of just straight up technology. Doesn't matter. We're going to have A has to be -2, right? That's from the first equation. Doesn't that mean that B has to be 2? And if you plug those 2 values into the third equation, you'll get C has to be -3. There's your particular solution. -2x² plus 2x minus 3. Your general solution is the sum. It's the complementary function plus the particular solution. What was the complementary function? And then plus what we just got. There's your general solution. The method of undetermined coefficients was just finding the particular solution. Find the complementary function is what we just did. And when we study variation of parameters, it's the same thing. You find a complementary function, and then the actual method itself is to find a particular solution. Then it's just complementary plus particular as your general solution. Same complementary function, right? Because it's the same thing, y double prime minus y prime minus 2y. Now finding the particular. G of x is e to the 3x in this case, right? So the form of our particular, a e to the 3x. But what you want to do is you want to check e to the 3x, does that appear in the complementary? Then you're good. If it did appear, your form would be x e to the 3x times a. And if that also appeared, then it'd be x squared, or a x squared e to the 3x, so on and so forth. Now the procedure is the same. Second order, so we want y prime and y double prime. What's y prime?
We had e to the 3.
What's y double prime?
9x to the 3.
Now just plug it in. Simplify that. That's going to be what, 4a to the 3x? And that has to equal just e to the 3x. Which means what's a? A is quarter. So your particular solution is e to the 3x over 4. Your general solution is then the sum of the two. And also notice that with the homogenous stuff, I didn't do any initial value problems. Because finding the C1, the C's using initial values is just a matter of arithmetic. And so I'm just focusing on finding the general solution. If you're given initial conditions, you can then find your constants. And it's the same thing here. I'm focusing mostly on just the general solutions, ignoring initial conditions. Same complementary function. But now g of x is sine of 2x. The form of our particular solution a sine of 2x plus b cosine of 2x, or flip the cosine and sine, that's perfect. Right, the reasoning behind why it's the sum of the two. What happens when you take the derivative of sine? You get cosine, right? What happens when you take the derivative of cosine? You get sine. So you have to look at their sum. What's the derivative? It's 2a cosine of 2x. Remember, for derivative, cosine is negative. For antiderivative, sine is negative. Keep going.
Minus 2b sine of 2x.
If you understand that saying. No, probably no. That's what that says. That actually makes sense. To be or not to be. What's y double prime?
Minus 4a sine squared. Minus 4b cosine squared.
And just as before, now we plug those into the equation to find A and B. I'm going to put parentheses. I'm also going to group like terms. So group your sines together and group your cosines together. So it looks like it's going to be what? Negative 6a plus 2b for the sine. And for the cosine, negative 2a minus 6b. And what does that have to equal? Sine of 2x. Right? From the equation. So what does negative 6a plus 2b have to equal? One. What does negative 2a minus 6b have to equal? Now solve that system with your preferred method. I'm going to show you how to do it in Wolfram. Two ways of putting it into Wolfram. I'm going to go this way. Braces, first equation. And I'm not going to use capital letters. I'll use the lowercase. Comma, second equation. And the braces. And I'm solving for A and B. And again, let me do it in table form. And there's your answer. The other way you can do it is instead of putting, lost my cursor, there it is, oops. Instead of putting the two equations in braces and separating with a comma, I keep losing my cursor, which is annoying. Just separating with a double ampersand. Either method works. So it's just whichever way you prefer typing it in. And if it was a system of like 4 equations, same thing, either braces, each equation separated by a comma, or outside of braces, each equation gets separated by a double ampersand. For some reason, it cut off the top, whatever. There's a particular solution. 1/20th cosine of 2x minus 3/20th sine of 2x. And that would be a general solution. So we can kind of examine this, right? What we looked at before, not too difficult. Calculus, and then the rest is algebra. Because then it's coefficient comparison, which is pure algebra. So again, it's kind of like just following a cookbook, following the recipe. Find your complementary function, which of course is going to have one of 3 forms for each root. Then guess your particular solution, find the form of your particular solution, which is based on g of x. Then solve for your coefficients. Start by finding the complementary. Let's not put a hyphen there, let's just use a vowel. So use that. So you need your auxiliary equation, right? M squared minus 6m plus 25 equals 0. Give me the solutions. What are the roots?
Three plus or minus 4y.
What's your complementary function?
Negative 3x times c1 cosine 4x plus c2 sine 4x.
You have the right forms, that's not correct. What's your independent variable?
T.
Replace x with t and you have the right answer. But I'm not going to write it in that form. I'm going to write it unfactored. This allows me just to more easily see what the two independent solutions are. What should the form of the particular solution be? I have a sine of t over 2, right? And a cosine of t over 2. That would be our form. Look at that form. Do they appear in your complementary function? So is there a sine of t over 2 as a linearly independent solution? Is there a cosine of t over 2 as a linearly independent solution? So you're good. That is your form. Now you have to find a and b. What's y prime?
Not a sine, cosine t over 2. And then minus 1/2 sine t over 2.
It's y double prime.
Negative 1/4 sine t over 2 minus b over 2 cosine.
And of course, you can write either b or 4 or quarter. B doesn't matter. It's the same thing, right? Now you have to plug those in. I guess I should have been using dots instead of prime notations here, but it doesn't matter. So I'll just write them as dots, just to be consistent. But it doesn't matter. We had y double dot. No, I'm going to cheat. I feel like rewriting. Oh, no, you're not going to let me actually copy. For some reason, my touch isn't working. Why is my touch not working? That's not good. Oh, that's annoying. Then I'll just copy it as a picture. Minus 6 y dot. Let's reset my computer. Good. It was what, plus 25 times y? And that whole thing has to equal two sine of t over 2 minus cosine of t over 2. Right, so combine like terms and then do coefficient comparison all in one is what I'm going to do here. Sine of t over 2. Right, so just look at the sine. Negative a over 4. And we're going to have a 25o here. What's 25a minus a over 4? 99a over 4? And then it's just going to be, what, a plus 3b, right? And what is that going to have to equal? Or this was for sine.
Two.
That has to equal 2. For cosine, so it's 25b minus b over 4 again. So 99 4 over b, and looks like negative 3a. Right? And what does that have to equal? So what's the coefficient on cosine? Negative 1. There's your system. I need a bathroom break. Stop it. You want to challenge yourself, try to do it without a calculator. get a solution? It's obvious. Obviously, that's the solution. You tell just by looking at it. So remember I said if you wanted to challenge yourself, do it without a calculator. And so you have to do it without a calculator. So you're given that as your solution to the system. What is the particular solution then? What was the A attached to it in particular?
Sine T over T.
And that's what, minus 20 over 663 cosine T over 2? That's your particular solution. Then what is the general solution? And here I think I will write factored. That's the complementary, right? Plus your particular. And that is the general solution. Good. Again, what's the hardest part of these types of problems so far? The algebra. Solving the auxiliary equation to find your complementary. Right? That's the toughest part of finding complementary. And then the actual coefficient comparison part is the hardest to find your particular. It seems to be a running theme in calculus, right? The calculus is easy. Algebra sucks. We have 2 problems left for undetermined coefficients. I think that's kind of a good place then. Finish those last 2 problems up on Tuesday. And then the worksheet. And then start variation of parameters. If you thought the algebra here was bad, variation of parameters is worse. It actually involves more calculus. But of course, there's good news to that too. We have technology that can do most of that work for us. What's after variation? Oh, I think after variation parameters is models. So that's next week's agenda. Finishing up undetermined coefficients, variation of parameters, and second order linear models. In particular, there's 3 I'm focusing on. Springs, RLC circuits, so Kirchhoff's laws, and motion under a central force. All of which, by the way, is physics. And then there's three types of springs. You have over-damped, under-damped, and I think it's called critically damped, if I remember correctly. But they're all generally the same. And so next week's actually a lot. It's 4 sections on models. Finish up undetermined coefficients, the section, 2 sections of variation around it is 2. I'm sorry, undetermined coefficients is 3. Chapter 5 splits undetermined coefficients into 2 sections. I think the first section covers exponential and polynomials. The second section is just trig. Which means your second project is also, or not project, your second group assignment is coming due as well, right? On July 10th. And the second exam will be that July 24th. And so you have time to fill out that green reference sheet. Give me plenty of time. Again, don't lose it if you're not getting another one. And that's the only reference sheet you'd be allowed to use. Plus what I give you with the test. You'll get that packet again. Have a good weekend.